Why do jellyfish undergo strobilation to reproduce? Imagine a tiny jellyfish polyp sitting quietly on a rock in the ocean. Suddenly, it starts to change in a fascinating way. This process is called strobilation, and it is a clever trick jellyfish use to make more of themselves. You see, jellyfish have a very interesting life cycle that switches between two main stages. First, there is the polyp stage, where the jellyfish is attached to a surface and looks nothing like the familiar swimming creature we know. Then it transforms into the medusa stage, which is the free-swimming adult jellyfish. During strobilation, the polyp begins to segment itself into a stack of disc-like parts called ephyrae. Think of it like slicing a loaf of bread into individual slices. Each of these slices is a tiny, immature jellyfish that can swim and grow into a full adult. The segments then detach one by one and become free-moving jellyfish, ready to start their own life cycle. This process allows one polyp to produce many jellyfish without needing to mate or fertilize eggs. It is a quick way to increase their numbers when conditions are just right, like in spring when water temperatures rise and food is plentiful. Environmental cues play a big role in triggering strobilation. Warmer water, more sunlight, and abundant plankton all signal to the polyps that it is time to reproduce. This timing helps jellyfish take advantage of the best conditions for feeding and growth. It also helps them spread to new areas, increasing biodiversity in the ocean. From the perspective of marine life and invertebrates, this method of asexual reproduction is a smart survival strategy. It keeps jellyfish populations stable and thriving, even if they face challenges like predators or changing environments. So, in simple words, jellyfish undergo strobilation because it is an efficient way to produce many offspring quickly. It allows a single polyp to turn into dozens of tiny jellyfish that will grow into adults. This process helps jellyfish survive, reproduce, and stay a vital part of ocean ecosystems. It is a perfect example of how invertebrates adapt to their environment and keep the marine world full of life.